Hey guys, nice to be here. Yeah, thanks for the intro. So yeah, I'm a computer scientist, so I hadn't anticipated 2 years ago that I'd sort of go into the legal world, but here we are. So all right, let me see if this works. Yeah, I guess we all know that nobody has more text piled up than lawyers. And so we have a database of 30 million legal documents. Since we were like working with US lawyers, that's where all that is coming from. Those are like from the courts that publish any kind of case that happened in the past. Yeah, and there are a ton of lawyers, and I always thought lawyers, kind of they sometimes get in the way, and make things more complicated than it needs to be. But they are like when you're building things in the world, you'd often come across some kind of legal issue, and if we make it much easier for people to and for companies to solve their legal issues, that would be a really great thing. And this is what we're trying to do. Most of the legal world still uses tools like Word and sort of rather old tools for like searching for stuff. But this is like right now changing quite fast. I think this is one of the fields that will be impacted the most abruptly from large language models. And yeah, we're just one of the young startups working on this. And so we're like 7 people. Is some sort of very naive, ambitious software engineers like me and the lawyer and the business guy all sitting in Berlin. And yeah, we are focusing like on, for the start on like a particular part of this legal research, because there are many different types of lawyers. And one thing that they spend many, many hours per day doing is trying to find arguments and finding cases that support these arguments. And as you can imagine, this is like a ideal NLP problem. You can describe some things about your case, and then you want to have like other cases that are similar and find whether they would match for like your requirements or not. And so yeah, like our main platform is going to be released in about 4 weeks. So this is like more of an animation, but basically the idea is the language models will like go through many cases, use some like embedding sort of like a vector database to find things that are relevant, and then also help you understand within this document that I got suggested which part of that is relevant and why. And so that the lawyer can actually verify, yeah, this information is useful for me because I actually can click onto this explanation that you gave me and I can verify it in the original text, and you just help me find that part faster. And of course, once you get a suggestion and say, well, this is useful, but I'd like a different direction, then this sort of kind of conversational way of refining a search over time is something that was also like not possible before. And these are like just small examples of many ways in which language models can help in the legal research process. And then after many hours of researching different cases, lawyers also like write a document and send it off to their clients or their other colleagues and so on. And this is also something that we're working on. And once you've collected many different arguments across your research, using something, it can just be ChatGPT that has all this data to come up with a draft is actually quite easy. And humans, you would still need to like double check it and refine it. But once you've got all the right information in place, the writing is actually the easy part. That's why perhaps it might not be as you think, that's most of our work is going into building the thing that does the writing well. It's actually more collecting the information and helping the lawyer verify what goes into the writing, and then just using some large language model that is pre-existing and combining that all together. So that was just like some context on what we do. I think for you guys, it's probably more interesting to see how is it like to build on top of large language models. And I, for example, have a background more in research. I was at ETH looking at sort of retrieval systems and how we can like use these large vector databases and so on. But it turns out that even though we all have like a strong NLP and deep learning background, that the most difficult things that we have to get right, as at least as an early stage startup, is more on the software engineering side, on how to design a great product, how to understand what the users need, and how to build the simplest possible thing. And oftentimes it actually doesn't mean fine tuning and spending lots of time with PyTorch and weights and biases. And it's more about connecting existing pieces in the simplest possible way. And making good guesses also like on which things will change with the APIs and with the models and frameworks available. So which things should we build now and which things do not make sense to build now because in 3 months there'll be something that is way more helpful than what we can build. So and a few things I wanted to highlight here is that perhaps some challenges that we were facing is vector databases aren't as good as you think they are. So if you want to search across many documents, we all know we can use these APIs or our own models to compute embeddings over documents or chunks. And this is how we do search in the modern era. Just turns out that there are a few problems with that. First of all, the databases themselves have less features than classical text search databases. So what we were missing was that the ingestion speed was comparatively slow. The filtering abilities, if you want to like set filters for which region, which type of law, which type of judge, which state, you can do that, but it's much more cumbersome and much more limited than what you can do with older tools like Elasticsearch. And also, when you compute embeddings, there are many different. There's some design space that you have, and there's really no know-how, no established practice on should you now compute the embeddings on the whole document, on chunks, or should you perhaps include some kind of summary for the document? And all these things have a large effect on how good your embedding search would be. But there's sort of no public know-how on which works best, and also no tools to help you with that. So you can either spend a lot of time experimenting and then recomputing millions of embeddings every time, or started with a simpler system or something else. And other problems that we had is like, for example, LangChain. You probably all heard of that. Super cool that they have all these search and QA and summarizing tools. However, we ended up moving away from that again because it's not so easy to customize. And whenever we wanted to customize something, the features that they offered were always slightly different to what we had. And so yeah, we ended up building those things ourselves again, and sort of ended up with a simpler and more flexible system for us. Yeah, and I guess it's funny that for us predicting the future became so important, because for example, we'd like to fine-tune our own large language models, like you said in the introduction. However, we noticed that most of the time we should wait until, for example, GPT-4 has a fine-tuning API, because the whole infrastructure needed to deploying these models at scale is something that we can do. We have the team to do that now, but it has very little advantage. And we should focus our resources on other parts right now. And if we build like an infrastructure to do this internally now, then another team that is just using the API and switching to the fine-tuning API as soon as that's available, and what my guess would be in the next 6 months, then they will have a huge speed advantage, and iteration speed is super important right now. So yeah, perhaps one other thing that we also get asked a lot is like, how do we avoid hallucinations? When we build tools for lawyers, of course, it mustn't ever invent stuff that isn't true, or be misleading. And there was actually, so what you see on the screen here was something that was fully generated by our tool. And you can see there's like a case suggested, a kind of a summary, and then a quote from that case. And sometimes when we like ask more specific things, you also get like more opinionated answers. And these must always be true. And hallucination, I still think that the next generation of large language models will solve the problem just with a different fine-tuning scheme. And there are like many ideas on how this could happen, but that's more speculation now. But what we can do now is, with the existing models, it's totally sufficient to just make sure that all the input that is necessary for the model to make the decision, and to answer the question, as long as that is all there in the context and the input, they don't make up stuff. Only when you ask it a question where the answer is not in the text it has available, it will start hallucinating. And you still need to do some level of quality assurance, some sort of manual testing, and perhaps even automated testing. We did it as well, like just asking an LLM to evaluate the other ones that work. But that seems totally sufficient, as long as you do that in the right way. And of course, we also assisted this by using excerpts wherever we can. So if we have these human written documents, we can of course just like show excerpts from that explain and that help the user verify. And these, even though they are sometimes selected by a language model, those are easily verified with Python. Yeah, this was like just a very quick sneak peek. I mean, we're now busy writing code and working on our first version. But I think now I'd hand it off to you guys for questions, or to the next speakers.
Cool. Thank you for that, Otto. Really interesting. Very much in line with very much trending topics at the moment. I know everyone's talking about large language models, and I know what you guys are doing at midpage is really, really interesting. Otto, I have some questions I was just writing down as we were speaking there. You built a ChatGPT plugin. Why did you do that?
Um, so of course, like this is a very new thing, so we also wanted to figure out how useful it is. But basically, currently there's no way of using ChatGPT and interacting with case law at the same time. So just like connecting that to a database, was easy to do, and we have like 3,000 users using it. Most of them are lawyers, and this is great because you currently can't use ChatGPT because it will just make up cases. And with this plugin, you can like use it to find cases, answer questions on that. It still hallucinates sometimes. We're about to fix that, but yeah, that was like an easy experiment on our side.
Yeah, cool. Sounds interesting. And then Chitan from in the chat actually does have a question. So he wanted to ask, are you using only English data or are you also using German?
English only.
English
No
only.
focus on the US, at least right
Cool.
now.
Cool. No worries. Do you have any plans to like expand that out to do um other languages as well?
Yeah, so definitely do. I mean, we live in Germany, most of us, and it's the US is by far the biggest market. We have way more data, way more users, and if you want to become a really big company, you should always go for the biggest challenge first, and eventually the same approach will be useful anywhere. So probably in 6 to 12 months or something.
Cool. Fantastic. And yeah, just one more question from my side. How was the development and also the deployment on this?
So it obviously depends on which part. Like for example, with a GPT plugin, uh, it's very much like a normal app in that you can have your classical. You have an API server in the background, so you can collect metrics on how many times was which API called and which filters did the people set for the searches. I mean, it is of course like anonymized and so on, so we don't see everything that is going on there. But the updating process is perhaps a bit weird. So we have our fast API server, we can update that. But if you want to update the descriptions of the functionality that it provides, this is something that the language model interacts with directly from ChatGPT. And there they have this review process where it takes something between an hour and 4 days before they allow you to get it out there. Yeah, and this product, anybody can like just sort of enter case law into the plugin ecosystem and sort of see all the plugins that are there. And we were like the first one that was anything to do with legal.
Yeah,
So anybody can just
cool.
go try it out.
And just one final question that Amal has in the chat for you as well. He's asking, is the product released?
Oh yeah, the plugin is released,
Cool.
and the main platform is not out yet.
Cool. Perfect. So yeah, you've got some more interesting stuff to come from mid-page. But I'm sure if you've got any other question, guys, we're going to move on to the next speaker now. But if you have any other questions, I'm sure if you drop Otto over a message on LinkedIn, he'll be more than willing to give you guys some more insight as to what they're doing there at mid-page. It's some really cool stuff. And thank you for that, Otto.
Sure, no problem.
Cool.
Bye, guys.
No worries. And yeah, now next up we have Tom. So just a short introduction about Tom. Tom works for a company called CareerFoundry, and he heads up the machine learning team. Now, what CareerFoundry are doing, they're an online tech school that is aiming to take people from a beginner to job ready within sort of 5 months. And they have loads of different ways they go about doing this. And what Tom and his team have a big focus on is actually building large language model online tutors. But when me and Tom were actually speaking, what we found is where he's building large language model tutors, it actually goes sort of hand in hand for large language model assistants as well. So Tom's going to speak to you today about the challenges of building large language model tutors and also assistants. So yeah, really looking forward to this one.
Thanks very much, Finley. I hope you can all see my screen okay. Yeah,
It's all good.
let's dive straight in. So why are we doing this? I mean, Finley's already covered some of the ground. We run career change programs in about 5 months, but we have limited staff available to help. We have pre-written course material, which is inherently static. We do see some churn in our student numbers. So we're trying to optimize that by producing personalized support. Yeah, there are basically 3 areas we're looking at, which is why I didn't want to pigeonhole it by tutors, because it's sort of a generalized assistance space. So the first area is sort of simple question answering on documents, internalized documents. So that could be your Wikipedia page or Confluence or whatever you're using. The second area is trying to reduce the need for data analysts. We have an internal data team and machine learning team, but we're always, we always have more requests than we can handle. So we're looking at ways we can get users to directly communicate with our data warehouses. And the third area is obviously for our end users, for the students, how can we produce LLM tutors and assistants that are there 24/7 to help you? It could be, rewriting, summarizing course material. It could be generating quizzes on the fly. It could be adding humor into the context, into the material. So a bunch of different areas. And so what are the challenges that we're facing? We're researching in this area. We're not as far along as Otto. We're still developing, and we also have a bunch of other ML products and services that we're also productionalizing. So yeah, first challenge is pre-built or custom infrastructure. There's a bunch, so you can use a pre-built interface, ChatGPT, and a bunch of others, and they have amazing plugins. Super easy to get started, and a lot of people have solved some of the problems that we're looking at. However, there are data privacy issues and lots of unknowns in that space. Or you can customize your functionality with a framework like LangChain that allows you to manage, prompt engineering, chat history management, data manipulation, so vector databases, etc., and agent control for more advanced functionality. Yeah, simplified architecture, super simplified, but assuming you have a sort of vector database process at the top, you're pulling in internal documents, course material, whatever it is, embedding it. And as Otto said, you face these issues around, do you chunk at the document level? Do you split your text at a lower level? Do you overlap, etc.? And all of those presents different problems. And then how do you handle storing metadata in the vector databases that make searching not just based on the language itself, but on, metadata. And then once that's done, user input comes in. There's an important prompt handling segment where you control user input, wrap it in sort of system prompts to handle things like hallucination and prompt injecting. Pass all that to the LLM. LLM pulls in the vector database information as well as the chat history, relevant history from the user. And then a second control afterwards, response moderation to ensure that the output is as good as it can be, and then that output goes to the user, who's hopefully happy. Yeah, next challenge, model selection. This is a rather confusing or rather busy page, but I'll try and simplify it. Basically, I'm interested in at one end of the spectrum taking something like Llama 2 and hosting it locally, versus at the other end of the spectrum just using a closed source API. And for me, the trade-offs are with a locally hosted, I've got hosting and latency issues, and I've got increased costs, but I have full visibility and total reassurance around data privacy, especially if you're handling the pipeline and the vector databases as well locally. At the other end of the spectrum, lower costs, less issues with latency, but it's a black box and you're SLA dependent. So yeah. Right, data storage and retrieval. I mean, previous speakers spoken about this, but there are some papers coming out highlighting the fact that scaling these transformer models up is not necessarily improving mid context attention. So beginning and end context attention seems to be strong. And obviously, as you scale that problem, increasingly your mid gets bigger. So storing and retrieving language data is vital. And yeah, people are using vector databases, but also traditional methods like Elasticsearch, and you can even use relational databases if you feel like it, or NoSQL databases. And yeah, you store the text as high dimensional embeddings, and then you use approximate nearest neighbors and some distance metric to retrieve relevant data. And here again, you have the option to use a locally hosted approach like pgvector, or something like Pinecone and Weaviate, where you get an API. And again, you're not in charge of the end data, so there's concerns or issues that need to be solved in that regard. Yeah. And then hallucination management, right? We all know about incorrect information. Controlling it is super important. So 4 techniques that we're using: model parameterization, so you can set the low temperature on many of these large language models. Try and penalize high diversity. And if you have full access to something like Llama 2, I'm sure there's more you can do in terms of fine tuning. In terms of data veracity, just try and get as much relevant information as possible in the vector database. Hallucination tends to happen when it's asked to sort of generate information it doesn't have source data for. Prompt parameterization, again, so like system prompting to try and control its desire to satisfy the user by generating false information, and then downstream control. So creating a bunch of test suites doesn't control for hallucination. Sorry, it's a bit of a typo. You just sort of are able to check ceteris paribus if your model is hallucinating on a fixed set of data that you generate or other people generate. Right, prompt hacking. Yeah, I mean, everyone knows about things like jailbreaking and prompt leaking and prompt injection, and there's a bunch of examples on the internet. How do we handle it? Well, again, it's I think recent papers are showing that this is not it's an inherently unsolvable problem. So I think you can sort of minimize the risk, but you can't essentially get rid of it. We're using whitelisted and blacklisted user input, so preventing queries coming from predefined lists, predefined special characters, things that might be indicative of prompt hacking. Same model parameterization as before, and same with prompt parameterization. Well, not the same parameterization, but the same techniques with different parameterization. Another challenge is legal and ethical challenges. So data privacy is a big issue. In the pipeline that you build, the language model is a big unknown. How's the end company using your data? Is it using it for training? Is it storing it, etc.? Where's it storing it? Same goes for the vector DBs if you use an API solution, and same goes for wherever you decide to host your solution. But of course, that would be the same problem irrespective of what software you're building. There are legal challenges underway. Stable Diffusion has a class action. I expect others will follow around ChatGPT and the other large language models. And European regulation is a big unknown. GPT was banned in Italy for a while, as we know. So the big final question is, ethically, where do you stand? Is the training of a large language model and its generation of new text, is that copyright? Is it not? Is it unethical? I don't know, but I guess we'll work that out as we go. And then finally, who are pioneers in the field from the LLM assistant space? In the left-hand side, Khan Academy has released a pretty cool LLM tutor helping their students to learn. At the bottom is Duolingo Max, so the LLM generative AI solution for Duolingo, and Dust as well, keeping it German. In the model space, I mean, I'm particularly excited about, if you look at like the Hugging Face leaderboard, Llama 2 with Orca fine-tuning, so the stable Beluga, I think it's called, is getting close to the top of the leaderboard, and that's fully open source. So whether you think that's a good thing or a bad thing, I think there are pros and cons. it's certainly exciting to be able to get your hands on the full caboose, as it were. And then in the community space, I guess everyone's familiar with Hugging Face. We're working a lot with Google in the Vertex AI space, and they're releasing a bunch of new functionality in the Gen AI space, which is great. Raza, a German NLP open source community, is obviously making moves. And then, LangChain is just indicative of the kind of frameworks that are opening up around this LLM space to help people like us, people like me, build useful functionality. So I think that's enough from me. Any questions or thoughts from the crowd?
Yeah, cool. We'll give it a thanks for that, Tom, by the way. It was really, really cool, really interesting. Very in line with like I said, the trending topics and the general consensus of what's going around at the moment. It's funny, I actually had a conversation with someone today about large language models, and they mentioned that the public sector is going to be one of the biggest sort of innovators within large language models. So it's really interesting, obviously, what you guys are doing down at CareerFoundry, and also, yeah, basically what you're creating is really cool. So yeah, cool. We got a question from one of my colleagues actually, Tom, here. So he mentioned, what was your main motivation in getting into like the AI/machine learning space?
So from a personal perspective, yeah, I've always been interested in language, and I have a master's in computer science, and for me, the intersection between the two kind of led me to NLP, which is the area I enjoy spending most of my time in. From CareerFoundry side, yeah, it's just about improving our productivity, scalability, so we can grow our user base without an equal and commensurate growth in operating costs. And we also think we can improve the service that we offer as a result. So yeah, I think that would be succinctly why we're in the ML space.
Cool. Yeah, and I was obviously, as you were speaking there, I know that when we spoke previously, Tom, we came up with some questions that could be quite interesting to ask. So how do you actually plan to deploy the large language model assistant?
Yeah, well, we're just gonna host an endpoint and let our downstream application interact with it. So it'll get embedded into the product as and when it's ready to. And we use Google for our hosting services.
Cool, perfect. And I know you touched on it a little bit about like the harmfulness and the privacy that goes into large language models, and the fact that Italy actually had it banned to ChatGPT for a little while. But what steps are you actually taking to address the harmful or inappropriate outputs that large language models might generate?
Yeah, I mean that's a great question. I talked about it briefly. I think the Italy thing was data privacy, probably, as far as I remember, which is the big unknown. What these models are doing with your data, and I think there was some news article about Samsung's data getting embedded into the training data for ChatGPT. I forget the exact details, but basically you can't be 100% unless you host a model like locally. But in terms of harmful and inappropriate outputs, I don't know. Obviously we're doing whatever we can. I think it's as I said before, it's not a problem you can completely eliminate. But as soon as basically existing prompt injections get publicized, we control for them, and we use techniques that sort of peers in our field are using to wrap around our prompts and to perform downstream testing. But yeah, I think there will always be a risk that will be exploited in some way, as if Meta and Google aren't able to, and OpenAI aren't fully able to mitigate it, what chance do you have?
Do you think that there will actually be separate roles potentially for people that will just do the privacy and sort of regulate the large language model alongside the people that actually deploy it and program it themselves?
Yeah, I mean, I hope so. I think that kind of leads into a great question about AI safety and AI alignment, which is, I think anyone in the field knows that all the hype is in the development, but not the safety and alignment problems. I mean, I think OpenAI just announced something like 20% of their budget over the next X years, 5 years, something like that, is going to be dedicated to the alignment problem. So people are moving, but there are bigger issues with, there's obviously the sort of, the Skynet paradigm or the paperclip paradigm at one end of the spectrum, but in a more mundane sense, things like, systematic biases in data sets, causing things like gender and racial profiling. These are big issues that people in their hurry to release the next great thing probably or might not be spending as much time thinking about as they could and perhaps should. So I'm happy to hear about the OpenAI news. I think I'd like to see more done on AI safety. However, as a practitioner in the field, I also am guilty of wanting to build stuff and not necessarily spending as much time as we could thinking about safety and biases. And so we really are making a concerted effort to make sure that that isn't the case. But I think my first gut reaction is just to like build something cool,
Yeah, just let it explore as much as possible.
Yeah. Yeah.
Cool. No, really interesting. Thank you for that, Tom. Love to get you on here again for maybe one to come in the future. But yeah, next up we'll pass over to Aref. Just a short intro about Aref as well. He's a freshly new business owner actually. He started a business called FlowEye with his business partner Thomas. Now, I think FlowEye are a really exciting startup business and definitely one to keep your eye on. They are focusing on anomaly detection for the logistics industry. So what we tend to find is a lot of things can go wrong in these large distribution centers. And sometimes it can take ages to identify the problem and creates large amounts of holdup. So Arif is going to speak about how FlowEye reduced the speed to find the problems and how they are looking to revolutionize anomaly detection with computer vision. So yeah, Arif, the floor is yours if you want to start off by sharing your screen.
Sure. I hope you can, yes, you should see my screen now. Thank
Yeah,
you
we can see it
for
all
the
okay.
introduction. And thank you everybody for joining. I'm Aref Ariyapour, CTO and co-founder of FlowEye, and I'm super excited to tell you how we are aiming to improve processes in intralogistic by detection and prediction of anomalies. When I say intralogistics, let's assume these huge facilities like the facilities that DHL or FedEx might have, and there is a lot of packages going to these facilities. There are conveyors that guide the packages through the system. Before we start, I want to say a few words about myself. In my career, I've worked on computer vision project, which was mostly focused on visual inspection. By that, I mean, the computer look at the stuff and they try to find a specific pattern or something important, like a damaged product or something like that. And also, I'm a big believer of collaboration. I believe great ideas come from teams. So I will use this opportunity to get your feedback. Please feel free to let me know what you think or the ideas you have or any questions. And yeah, let's start. So in the earlier stages, we did some research about parcel shipping, and we realized that the e-commerce is driving a huge growth in global parcel shipping volumes. As we can see in this chart, the parcel shipping volume is predicted to increase by over 50% in the next years. So we can feel the need for a proper monitoring system for parcel shipping. Next, I want to talk about a little bit the problems that are already happening so we can get a kind of sense why we need this kind of systems. This is a use case that happened in recently in 2021. A letter was delivered almost after 105 years. And when the letter was delivered, unfortunately, both people were not living. And the reason was that when they sent this letter was lost somewhere in the office, in the corners of the office. So this is a very good example that things could get lost forever in this kind of industry. And nowadays also, people, when there is a problem with their parcel shipping, you have to reach out to the company, to the parcel shipping company, which basically is not their main purpose. If things work properly, you don't need to reach out to the companies. Where is my package? I have to stay behind this answering machines. And sometimes the goods and parcels could lose their value as there is delay in delivery. Imagine you order a phone and you don't receive it in a month. You receive it after a month, and it can happen that new versions are coming. So it's very important to have a proper monitoring system for parcel shipping, since it is also going to grow dramatically in the upcoming years. And yeah, this kind of delays or damages breaks the trust between the customers and the service providers. Here also, I wanted to show the main prominent problems from the customer points of view. These are several different problems, and the ones that I have put the check sign are the ones that we can address with our products. For example, someone has to stay at home at an inconvenient time for the parcel to receive. In theory, if the delivery company is doing things efficiently, the customer should choose when I want exactly the parcel to be shipped. If the parcel is damaged, then it has to be detected before we deliver it to the customer. If the parcel is late, there would have been a problem in the shipping process. So by this, I want to say that we are aiming to address at least 50% of these problems by our product. Here, I want to talk about a little bit more about the kind of anomalies. We are saying we detect anomalies, but what are the anomalies that cause damage, that cause delay in deliveries? This is a kind of simulation of these facilities. These facilities are huge places that sometimes you need to, as a personnel, you need to walk with a bike or a scooter. And there are several conveyors, shelves, and a lot of things can happen. So it's a place that is prone to different kinds of anomalies. But the ones that we have already detected, recognized and want to address them in our product are like blockages. Like there is a lot of boxes on a conveyor and it stops the whole system to work. And sometimes getting rid of these problems can take hours. And this can cause a huge loss in profit, in trust, loss in customers. There could be doubles. For example, you scan a package, you put it on the conveyor, but along the way, from somewhere, another box falls beside this package, and nobody knows. Nobody will know about this second package that fell beside this package, and it can get lost. But if you are if you have always some kind of eye on the flow of these packages, you can always detect this kind of stuff. We can address lost items in these facilities, like the example I mentioned earlier. We can also address theft when the packages could go out of the facility. Theft can happen, and we probably can also detect that. Unknown workloads, bottlenecks, we can statistically show that, okay, here there is more kind of packages are arriving and they cause a little bit like a bottleneck. We can detect the damaged boxes. If the box was damaged somewhere along the way, we can definitely look at it and identify it. Integration errors, manual errors, and unexpected items. These are all different kind of anomalies that can happen in these facilities, and we are trying to address that to reduce the losses for the company, the shipping company, and also more convenience for the customers themselves. This is a small overview of how our architecture works. So the main algorithms are computer vision. We are working like a kind of artificial eye, looking at the packages, trying to see if everything is going fine. So as eyes, we have these different units, edge units, that they have some processing power inside them, and also some one or two camera attached to them. We put these units in different places in the facility, and we try to cover their, we try to make their view cover most of the important spaces. Also, these different units installed in the facility can communicate to each other, and also with a server, which will be probably on the cloud, or it can also be local. It depends on how the customer needs it. They can, for example, imagine if the unit detects a kind of anomaly, it can send log data and notification to the server, and the server is also connected to the user interface, which will be desktop and mobile app that I will explain a little bit later to inform the people about it. And there is also a SCADA, which is kind of a system, works with the conveyors. And we will also integrate. So if we find a kind of anomaly, we could stop the conveyors and ask people to fix the problem. This is an overview of the backend and frontend. The backend consists of mostly computer vision processes. We detect the packages, we detect the conveyors, and we track the packages. On the other side, in the front end, we have this user interface, which one version is desktop, and the other version is mobile phone, because nowadays everybody has a mobile phone, and if we can send notification to personnel to their mobile phone, that is already saving time. And this small unit is our unit would look like this. Here, I want to also show you how the backend works. We have several cameras in the facility, and we are trying to detect and track the boxes, not only in one stream of video, but through the whole journey of the package in the facility and through different units. As you can see, if we assign let's assume we start from camera 1, we assign an ID to a box, and when it leaves that camera and goes to the next unit, the units communicate with each other that this box with this ID left, be careful. So check if the new box comes, check if it's this one, and give the same ID. Having all this information, the box, knowing where are the box, tracking the boxes, and also detecting the conveyors, having all this information at hand, we can play around with it and come up with other solutions, like if the box is on the center or if the box fell down. These are all the things that we can do with our product. And this is again kind of user interface that can provide information about how much efficient one conveyor was. We can also provide a statistic about them. For example, conveyor sorter 1 had more downtime compared to the other ones. We can even generate predictions based on these statistics. We can always tell, be careful more about the sorter 1, or probably this will happen if this package reaches this conveyor. This kind of predictions we can also do. And at the end, I want to address why we decided to go with the edge units. To be honest, this depends a lot on the problem. So in our problem, we need the real-time detection and we need to react very fast. Therefore, we cannot send the data through the internet to a cloud, perform an inference over there and receive the results here. Because of that, we decided to go with the edge units. And I believe edge units also bring a lot of advantages. I would say the latency is reduced, which is which is something that we need for our real-time detection. It reduces the transmission of the data between remote servers that data privacy issues are reduced in this case, that we process the data right at the place. And I believe there is also sustainability and less energy consumption when you design your software for a specific hardware. Imagine I do the inference as soon as I receive the data on a very small unit. But if I wanted to do it on cloud, I have to transmit my data, which is a video, which is very big, the kind of data, through the internet, perform inference on a huge model in the internet, in the cloud, servers in the cloud, and then send it back. This is definitely much more energy consumption than using a very small modern neural network model designed for this specific hardware to produce the predictions right at that place. I hope I was on time, I guess. And please let me know if there was any question.
Cool. Really interesting. Thanks for that, Aref. And you maybe one question, then we'll see if anyone has any questions off the back of it. Yeah, something that obviously I know that we've spoken about a little bit in our conversations, Aref, is your solution only specific to the logistics industry, or is there plans to go into other areas as well?
We are in a very early stage, and at this point in the next few years, we are focusing only on this problem because it's already a kind of very complicated system to implement. But I believe it is also applicable to several other industrial areas. Like if you have some production line that you are looking for, again, a kind of anomalies, like if the product that you are producing on the if the product is damaged, you can use the cameras to do that. Or I remember there was also for some battery companies, they wanted to have cameras to look at their some specific part of their facility to look if what they produce, it was like I believe foil, if there was some kind of broken parts or something wrong in these areas. So I think there are a lot of industries that can benefit from this anomaly detection on the fly using computer vision. And when we are successful with the implementation of our product for intralogistic, I believe that's a good idea to further expand in those areas. And like one of our, I think it was Otto, mentioned that you have to address the biggest challenge first, and after that the rest would be easier. And I believe when we implement this, going to the other industries would be much easier for us since we have this implemented.
Yeah, 100%. So focus on the logistics industry to start off with. Once you've built that out, then you can start venturing out into some other areas. Okay, cool. I've got one more question as well before we move on to, last but not least, Giulio. But yeah, why are you choosing edge devices over the cloud, I guess?
Yes. Like I mentioned, it is very problem specific. For some problems, you don't need edge devices. I can give you an example. For example, I've worked shortly in a sports analytic company, and what you want to do over there, you receive the data, you perform your analysis, and then you send the data to them. At this kind of project, real-time performance is not the main issue. You don't need the algorithms to be super fast. But for problems like autonomous driving, that you need to do decision making on the fly and as soon as possible, you need to have very optimized algorithms, very good hardware, so you can do your decision making on the edge, on the device, right here where the data happens. Imagine, for example, autonomous driving company sends always the data, takes the video, sends to the internet, and waits for the internet to come to do the inference and get their data. This could be problematic regarding the latency, and this could cause huge problems and even could endanger people's lives. So latency, in short, I would say, is the most important thing here to decide if you go with the edge or not. And for us, latency was very important because these packages could move fast in the facility. And if we cannot do the decision on the fly, we basically cannot do the monitoring. So going with the edge device was necessary for us. It brings a lot of challenges, like designing very small models that can do high accuracy stuff.
Yeah.
On the other hand, there are also some advantages that I mentioned, like data privacy issues are less happening and energy consumption would be also less.
Cool. Interesting. Yeah, we have got, I said last question, but we have got a question from someone in the audience. So Yagadish has asked, how accurate is this tracking system and how do you handle predictions, if any?
All right. Definitely, we are in the earliest stages. I mean, there are several parts regarding the accuracy. We have the accuracy of detection and tracking of the boxes, and we have the accuracy of anomalies. I can say that currently we are around, for detection and tracking, we are around 60-70% of the times we can detect and track the boxes. But in order to make this product work, we have to gather the data, we have to go to these facilities. This kind of project is a little bit hard to do it with yourself and team in an office because you need the data from these facilities and you cannot find the proper data on the internet. So I can say at these earliest stages, the accuracy is not very good, but as soon as we get the access to these facilities, we can improve our improve our detection algorithms by gathering the data, annotating them, and training over and over.
Yeah. Cool. One more question as well has just come in as you were speaking there. Can you use Elasticsearch for tracking?
I am not familiar with Elasticsearch. I'm not sure what it is, but maybe if I get a quick short description.
Yeah, maybe we can look into that afterwards, Aref, and yeah, Krishuk can maybe ask the question to you and look into it a little bit further with you after the meeting. And yeah, no worries.
Sorry for that. I
no
don't
problem.
have knowledge about that.
No problems. Obviously, Elasticsearch is probably a little bit different to what you would normally do in a day-to-day basis as a computer vision engineer. So it's probably not something that you would have picked up on, Aref, so much so. Cool. Marius has also just asked a question. Seems like there's a lot of questions flying in. Is it also to contribute optimizing transport loads, for example, on the size/location of packages?
Could you please repeat the question again?
Yeah, sure, no problem. I'm guessing what he's asking is, are you able to optimize transport dependent on the load and the size and on what location it's going to, if that makes sense?
Yes, of course. Of course, this is something that we have to deal with it, especially in these facilities. We have to be careful if a huge package is going somewhere that is not supposed to be. It was called unexpected anomaly. We have to be careful about the size of the packages. And if it's going to somewhere that is not supposed to be, we can stop it. We can inform people about them. And yeah, of course, in the when we get to use this product more, I believe we can also, when we integrate our device also with SCADA, the kind of system that interacts with these conveyors, we can also reroute different packages based on their size or their type.
Cool. Interesting. No worries. Well, Aref, it seems like a lot of people are definitely interested in what you're doing. The most questions so far. So that's good to see. Cool. We'll move on to, thank you for that, Aref, by the way, and we'll move on to Giulio now. So just to give you a short introduction about Giulio. He's highly experienced in the field of AI within the pharmaceutical and healthcare industry. So he's got over 20 years of experience and works for the likes of Fraunhofer, Centogene. So you could say he's an absolute expert in his field of work. Giulio will be talking to us about how AI is changing the pharmaceutical and healthcare industry. And yeah, something that's a trending topic at the moment for sure. So I'm really excited about this one. So yeah, passing over to you, Giulio, if you want to start by sharing your screen. Yeah, we can see it all good.
Right. So thanks everybody for staying with us until late. But it's nice we have questions. That's the whole point of having this. Maybe first of all a little bit of clarification. I have a lot of experience, but also wide experience in other domains. That's why also I'm giving a presentation on higher level kind of compared to the previous ones.
Sorry to interrupt, Giulio. Just want to confirm with everyone. I've just had a message. Can everyone see the PowerPoint presentation all okay? Just before we go along, someone can put something in the chat for me. Okay, cool. Perfect. No worries. No worries. Carry on, okay. Giulio. Sorry.
Cool. Yeah, no problem. No problem. So as you can see, I started a very different kind of foot. As a philosopher logician, I didn't get much job. As a philosopher, and I went into software development, but still in the clinical and medical domain. This was in Italy. Then I went to the UK in Belfast, working in data management and system management, databases in the public health. But then I studied other things like astrophysics, bioinformatics. I started to get into the research in the medicine over there. And then I specialized in machine learning, in NLP, actually extracting information from pathology reports. Then I also was interested in data science. When I came to Germany, I went into machine learning of brain images, predicting the phenotypes from brain images. And in Fraunhofer, I actually worked on dialogue systems, question answering, when before all the large language models that are much helpful now. And then really, again, back to the biomedical domain in the target discovery. But anyway, yes, I don't want to take too much time introduction, but first, maybe a lot of you are not very familiar with the problems of developing drugs for diseases. The main thing is that the process is very long. It's very long and takes a lot of money as well. So here you can see a little bit of summary of the 10, 15 years that takes, from understanding what could be the target of a drug to actually developing the drug and the molecule, checking that it's toxic, not toxic, and it's actually having the effect that it's supposed to have, and then starting to test this in humans, and then having this approved. So this is very long, it's very complicated, takes a lot of money and a lot of people. And here AI has already been showing its effects, where it actually can help. Here, for example, you can see that you can use AI, for example, to understand, okay, what is the target we want to act upon with our drugs. But then we have to screen, for example, how all the drugs, all the molecules that we know, which one is going to work on this. This, of course, looks like it's a heavy problem that you can do in vitro, for example. You can screen practically in the chemistry, but you can do this virtually, and so on. But to make a little bit more concrete what I'm talking about, I wanted to give you a sort of a case study of a particular disease. This disease, idiopathic pulmonary fibrosis, without going into detail, it's a disease where some cells start to produce too much connective tissue in the lungs, and then of course the lung efficiency is going to be reduced greatly. So if you remember the diagram before, so there are two main things that you want to understand. So what are the reasons why these cells are actually producing this abnormal behavior? So this is about finding the target, finding what is the protein, what is usually it's a protein in the cell, which is maybe not well formed, or it's interacting in a way that is not correct. And once you find this target, then you have to see what can we do to actually fix the problem. So what is the molecule, the drug that can do this? How can we design it? And I use this example because I don't know if you heard of it, but in Silicon Medicine is one of the main players in this field currently, because they have created AI pipelines on this initial steps, finding the target using multiomics data sets, and once you have the target, try to understand what kind of drugs, what kind of molecules could be used, and then synthesizing it, and so on. And the most important thing is that they have managed to go to actually clinical trials, which is the latest stages of the drug development, and these are I think the first ones who managed to do this completely AI based. Now we're actually in phase 2, and so why this is interesting, not only because it's much more efficient, but actually is a huge improvement. All these phases up to phase 1, I think usually it takes around 400 million to get there, and they manage with sort of a tenth, and only that those steps take 6 years usually, and they took less than 2 years actually in this case. And also with all the tools that they have, they also can sort of be confident that there are higher chances of success. And for example, going to from phase 1 to phase 2 is usually very rare to get to that sort of passage, but they managed to do this straight away. So this is already an achievement on its own. Just to be a bit more technical, otherwise it's going to be very abstract as well. It is just one of the millions of examples where AI could actually be helping. So as we said, we have a target. So target is a protein that is produced by a gene, which is causing or is causing or modulating the disease. So what we have to find is a ligand, a small molecule, and see how this is going to bind with this protein, so that the protein is changed in a way that the disease is rescued, as you said. Maybe the symptoms ameliorated or is completely removed. Oh, this is a huge problem because it's called molecular docking. And in the past, you used search-based methods, took ages, very slow, and accuracy is not huge. Then, deep learning arrived, became much more, much faster. Still, accuracy is not that great. And lately, in this particular study here, DiffDoc, this paper, if you want to check it out, they use diffusion models. So it's a generative model that is increasing enormously the way they could actually test the way these molecules can dock on the surface of the proteins. So this is coming from a completely different domain. Images generated by diffusion models are very realistic, but this is an application which is completely novel. It's very exciting. But then if you go to the healthcare, more close to what the news could be, I have just seen this a couple of days ago. There is this sort of review article in the National Institute for Healthcare and Care Research. And you can see 10 different sort of cases where they have collected information from tools that actually exist and have been used from sort of helping doctors to detect anomalies or diagnose from images or understand how the progression of disease could be, or even helping in the managing the resources, allocating the resources in the healthcare process, or personalization, for example, decision support personalization. So these are the ones which are sort of easier to understand, to also showcase in communicate to the public. So if you also go to these consultancy companies and when they talk about what are the applications of AI in healthcare, usually they put the research, this is the pharma part in one of the domains, the subdomains, but the rest are quite numerous. So starting from training, we have seen training, how it can be affected by or greatly ameliorated by AI. But then again, everything in terms of prediction, diagnosis, detection, decision-making, all these things that actually you can see that on the end of the day, they are also very related to other industries. So they're not very, very specific to the healthcare. And, but what you can say is that in a way, it's not like understanding where are the parts or the domains of healthcare and pharma where AI could actually contribute. It's more a matter of being creative and understanding, how you can use AI to actually improve this or that particular subdomain, because the limit is really the sky in this case. But to give you also a concrete example of, in the case of the healthcare, or in this particular case of self-care, which is one of the things that McKinsey mentions here, this is another project. I am actually still involved in. It's a Europe-Japan Horizon project, and we have been developing for older people dialogue system for guiding them in their daily life, daily activities, using the system sort of personified by these devices like holograms or small robots or other things, that can actually be seen and interactive instead of a screen. And why I'm doing this particular example, because this example shows how these things have changed so fast in the last few months, to be honest. I mean, this project started 2.5 years ago, and we started, I mean, also thankful to Tom, who actually introduced sort of the natural language processing and dialogue system in the higher level. So we started from a semantic approach where we said, okay, we can use knowledge graphs, this representation of knowledge in a graphical way to do question answering and dialogues. That was very time consuming. It was very hard to get up on, and we were using Rasa. I think, well, Tom, you mentioned that as well. And then we said, okay, this is not going to work very well. We now use the scripted approach and language models. And then just a few months ago, like just the last few months, with GPT-4, GPT 3.5, actually, we are using the APIs. We said, okay, now all this actually is not obsolete, but almost. So we are actually saying that all the scripted dialogues that we have created are almost a supporting or starting point where the user can actually use the API to OpenAI and query or dialogue on the content using these interfaces. I'm not sure about the timing. Maybe I can skip this one, but if I have time, yeah, I can just go ahead and say very.
It's fine. It's
Oh,
fine,
cool,
Giulio.
cool.
Just finish it. It's completely fine. You go for everything.
Cool. Okay. So this is a bit more technical, but without going to the barrier models, the dialogue systems mainly are concerned with understanding what the user is trying to ask the system. So this is called the natural language understanding part of the system. So the user says something, and the system is trying to say, okay, is it trying to ask something about, I don't know, how to prevent falling down, or are they asking how to get cool because it's very hot today, or are they asking about what is the weather? So this is trying to classify the intent. So it's called intent classification. And because we were using this dialogue scripting way of making the stories, this classification is used to send then the dialogue stream into a certain kind of flow. And this is when the intent is correctly classified or with a certain confidence. Otherwise, there is a fallback intent, and means you just find the closest that could be, but you are not sure. Now, what we have done is actually augmented this with, as Tom sort of explained as well, with the OpenAI API, with generative models, but again, using, of course, LangChain and providing the prompt engineering to have this responses from OpenAI restricted only to the content, so that when the user is speaking, there is a story, or then it gets exhausted because there is no more scripting there, or maybe the intent is not very well, when very clear, so it's not clear what story should be starting. We have this API that can be used, or the user can actually go directly in the so-called AI mode and say, okay, I want to actually chat freely, and there is no scripting there. So we just go directly into the chatting mode. And talking about what Tom was actually mentioning, hallucinations and going out of the script or the domain. So far, we have actually not experienced much of that, because we have managed to restrict this with prompt engineering, with some other techniques, so that actually when the user is asking something which is not contained in the guidelines or the information, the documents we have provided, the system actually says, oh, I don't know about this, I can't answer this. So what can we say in conclusion? So yeah, I mean, we have seen from everybody that the ML, AI have revolutionized all the industries, and in healthcare, I have to say actually there is a long history. There were very old attempts to try automate the diagnosis of diseases with rule-based systems, which are still classified under sort of an AI umbrella. And recently, I mean, sort of recently, pharma has been accelerating a lot in this because it's traditionally more conservative, but now we are seeing the results. Although now we really need the drugs into the market, otherwise, the investment will start to dry up a little bit. And if you want to restrict a little bit to Germany, I have to say Germany has always been a bit conservative in terms of digitization. Personally, when I came to Germany in 2015, I found digitization a bit behind the UK. I was coming from the UK. I said, okay, here you get to do a lot of paperwork and talk to people all the time. But I have to say, COVID, was a horrible thing to happen, but it actually improved sort of the way Germany was looking at digitization. So I think actually now there are a lot of things that are happening on the web. You can do this quite quickly, and then people are starting to enjoy it. And actually, I have to say the people are much more positive, towards the digitization more than the government, I have to say, or the institutions. And I think it's a good timing because now again with all these tools, becoming more and more complex, but also easy to be used and how would you say applicable to all different domains and use cases. I think it's really the right time. The only problem is, of course, in the domains where the data is very, very little, like, for example, rare diseases. But then there are a lot of research going on in terms of trying to for example, transfer learning and other approaches where you can ameliorate this. So last mention about, again, the generative, or some people say we're going toward the general AI. It's been very unexpected, as I said. We changed this project, very quickly. Maybe a lot of people will found a job not lost, but well redesigned in a way, even developers. But what I think is that we should not sort of throw out the old semantic approach to solving problems. So the knowledge that is embedded in a explicit way into databases or knowledge graphs should still be, I think, the backbone, or going hand to hand with the statistical models to make them interpretable and to make them more flexible. So I think, having said that, I think it's a very exciting time to live in terms of AI and machine learning, but science in general. And that will be me.
Thanks for that, Giulio. Really, really interesting. I think it's cool to see how much automation is going into the pharma and healthcare industry. And I know from looking at social media and then the news, it's a very trending topic. So I'm sure people really appreciate you sharing all your knowledge within this field. Cool. One from Aref, the speaker himself. So he's saying, do you think that the simulation and reinforcement learning could potentially help within healthcare?
Yeah, I mean, simulations, for example, yeah, there is a lot of development in different fields. One is simulating for example, or trying to predict by simulation the outcomes of clinical trials, how successful those could be. This is also a big obstacle because sometimes, you have these process going up to clinical trial, and you have phase 1, phase 2, and it fails. And then you have spent so many millions and so many years, and everything is gone. Reinforcement learning, actually, I'm a very big fan of it because, as I said, I would like to actually see more knowledge injected into the models, into the way the learning happens. So with the reinforcement learning, you can actually steer your learning in a way that is sort of pre-conceived in an expert fashion. And there are also studies there where we can use again, knowledge graphs or things that are modeled with knowledge graphs, where the the actual result that you want should take a certain shape. So, for example, just a very short example, if you want to find a drug which is might have an effect on a certain disease caused by a gene, then you want to have this drug to have certain characteristics. And you can model this in a way that is coming from the experience of all the other drugs that are affecting the diseases, and you can extract rules from that you you can use in your rewards in the reinforcement learning, so that there are constraints there. I think it's actually one of the best ways to do this.
Cool. Interesting. And then you mentioned towards the end of your wrap up, Giulio, about combining the best of the somatic worlds and statistical worlds. What do you actually mean by this?
Yeah, I actually have a backup slide for this one. Because yeah, it's a bit hard to explain without maybe not everybody's familiar with knowledge graphs. So knowledge graphs are these sort of um, artifacts where you have knowledge which is represented by entities and relations between entities. So let's say you're taking Wikipedia, you have all these links, these, for example, these info boxes on the right-hand side where you have I don't know, a person or a city or whatever. And these are all relations that go between the entities. And if you build a graph like this, which is huge, and then you have big knowledge graph, this is something that can be seen as established knowledge, semantically grounded, and it's taken from the experts. And then you can have also different kinds of graphs coming from encyclopedia or from common nonsense, common sense or common nonsense will be a, a bit of a problem, where, for example, you can inject this understanding of the world, which is not actually in the models, in the language models, because they are just statistically providing your answers, and so on. I mean, specific or even multimodal. So in a way, you can use knowledge graphs to help to make knowledge explicit and reduce the hallucination by giving explicit information, and then also can be also modified because, for example, if you have a language model that has been trained on, let's say, on Wikipedia or the whole web 1 year ago, a lot of information is obsolete. But if you have a knowledge graph, for example, which is taken, script maybe every day from some source, then you can have this always up to date. And then, of course, knowledge graph, these are quite general, but if you are domain specific, like in the biological domain, you have a lot of databases and data sets which are possible to be made in this form. So by this, coming back to your question, so knowledge embedded, sort of encoded in knowledge, like knowledge graphs, they can help the large language models, statistical based models, to be more grounded to the truth and sort of steer towards what you actually want them to do, and vice versa, because knowledge graphs, as I said, beginning were the big thing for question answering, for example, and they're still quite a big thing, but they have their problems, and in a way it's the complementing of working together. And this paper is quite recent as well, so if you haven't seen this one, you can actually look at all different ways these two approaches can be combined together.
Cool. Really interesting. What we're actually going to do after this, after we wrap all of this up, we'll post like all the PowerPoint presentations, probably on like a LinkedIn post, like some separate posts. So you will get an opportunity to go back through it. And yeah, like Giulio said there's a link that you guys can click on, go and check out like the most recent article that's very much linked with this page that he's talking about. But yeah, thank you very much for that, Giulio. It was really, really cool and some really good insight there.
Thank you.
No worries at all. So yeah, I'll just wrap this up. I appreciate we've gone a little bit over, but the timing went pretty good. So it's a well done, everyone. We're going to try and make this a regular thing. So we're going to actually be doing another event towards the end of September. We have got a date confirmed for showcasing innovations and in machine learning and computer vision #2, which will be happening on the 27th of September. So Wednesday, the 27th of September, same time. This will be 6:30 p.m. till 8 p.m. CET. Got some exciting speakers already confirmed, and a couple of others that we're in the pipeline speaking to. So really exciting. We're also going to be looking at hosting some other events as well. So you might have seen my colleagues Louis and Cam, who are also in this meeting and are also representing SR2 and FTG. They're going to be doing some events and have some upcoming things around talks on DevOps, talks on product. We're going to have some talks around data engineering as well in the future. So yeah, really looking at building this community out, and I appreciate everyone's time, and thank you for coming to join us on this Wednesday, and thank you to all the speakers, and we look forward to working with you guys further.